The word efficacy is something you've been hearing a lot in the last couple of weeks, especially with many of the COVID vaccine developments reaching their hopeful finality. And you're hearing all about efficacy or how effective these vaccines are. These are the efficacy figures, ladies and gentlemen, of the main vaccines that are being developed right now. Pfizer, 95%, Moderna, 94.5%, Sputnik 5, which is in Russia, 92%, Oxford, AstraZeneca, 90%. All pretty formidable figures since these vaccines are not ready yet. So those are promising figures that fill one with hope. But let's show you what the efficacy figures are of existing vaccines, the vaccines that you and I have already taken or will take perhaps in our lifetime. Take a look at this. These are all familiar vaccines. DTP for tetanus, diphtheria, etc. 100% is the efficacy. 100% is the hepatitis B vaccine. The polio vaccine is 98%. Many wouldn't know that the polio vaccine isn't 100% efficacious. 98%. MMR for rubella and mumps, etc. 97% is the efficacy there. So these are the figures I wanted to give our viewers, because a lot of people have questions over why is it only 95%, why isn't it 100%, should it not be 100% when it comes to something like the COVID vaccine. So these are issues that people have in their minds and hopefully will get clarified as we move forward. Dr. Parikh, I want to come to you first. On the issue of efficacy, I just want you to, clarify this for us, because we're entering a very crucial phase of, the crucial phase of these vaccine developments, where we're hoping to see more finality in terms of the results of these vaccine tests. I'm sure the Prime Minister will be briefed on this tomorrow when he visits the front line of many of these developments as well. Explain to us what the country is going to be looking for in terms of efficacy of vaccines.
Hi Shiv, thank you for having me on. It's always a pleasure to be on your show. When we talk about efficacy, we're talking about the ability of the vaccine to prevent either infection or to prevent severe disease. Different vaccines are geared to do different things. Ideally, one vaccine does everything, but a vaccine could allow you to get infected but just prevent severe COVID-19. Or it could prevent you from getting even a mild, moderate infection. But even a vaccine that prevents you from getting mild, moderate, severe disease may not stop you from transmitting the virus to others. You may just get infected without symptoms but still be able to transmit. So when we look at efficacy, we have to qualify that. Are we looking at efficacy in terms of the inability of an individual to transmit the virus? Are we looking at protection in terms of severe disease? Different vaccines are looking at different things. Still some time away from knowing which vaccine is going to have what kind of efficacy. When we first started out, we were hoping many of the trials were geared to finding 60% efficacy. From what we know of this virus, we estimated that about 60%, a vaccine that was 60% efficacious, we would have to vaccinate about 90% of all the susceptible individuals, 90 to 100%, to reach herd immunity. Vaccine-generated herd immunity. With a vaccine that's more effective than that, we're better off. We have to vaccinate less people to prevent transmission, if the vaccine can stop transmission. But, Shiv, there's also a critical difference that we need to understand between efficacy and effectiveness.
Yes.
Efficacy is something we talk about in clinical trials, where we know that every individual gets the correct dose, well, not in the AstraZeneca trial evidently, but everyone gets the correct dose at the correct time. They aren't lost to follow-up. They get the booster dose, that the cold chain has been maintained. When we know all of those factors are controlled, that's when we talk about efficacy. But in the real world, how effective is it going to be? Because let's say someone misses a dose, or they come in for the second dose 2 weeks late, or they get only half the second dose. Or there's a cold chain failure.
Okay.
What is then going to be the impact on the effectiveness of the vaccine?